Hello, and welcome to the Mathematicians Podcast, the podcast where we follow the fascinating stories behind the people that count in the history of maths. I'm your host, Benjamin Cornish, and today we are sitting down with a nice book and a glass of wine in a book club special. That's right, the episode number is palindromic in base 10, which means it's time for an episode of The Injectives, a sub-series where the function is I talk one-to-one with someone far more qualified than myself. May I introduce you to Thomas K. Briggs, author, maths communicator, and museum learning consultant. Welcome, Tom.
Hi, Ben. Thanks for having me. How are you doing?
Very well, it's a pleasure to have you here. Now, Tom has been invited here today as the author of The Mathematicians Library, a book with a similar enough title to this show that I just had to buy it. Although I noticed that you put the apostrophe of your own title in a different place to mine. So this is the podcast about mathematicians. It's the Mathematicians Podcast, whereas your book is Mathematician S apostrophe. So these are the library books that belong to the body of mathematicians, as opposed to the books that a mathematician is likely to have on their own shelves. Is that right?
Yes, I kind of see it. I just to be absolutely clear with this, the Mathematicians Library that I've written about is an entirely fictional library.
Okay.
But like all the best entirely fictional things, they exist. This one exists in my mind and hopefully in the mind of everybody who reads the book and some other people as well. And I kind of envisage it as being a bit like that big archive at the end of Raiders of the Lost Ark,
Oh, yeah.
and it's presided over by a librarian who is an orangutan.
Obviously, it has to be. Okay. So these aren't all of the books that are cramming up your library at your mansion house, I assume.
Oh, absolutely not. My mansion house is a tiny flat in Milton Keynes, and we don't have space for books. We've got lots of books, but we don't have space for the ones we've got. So I can't start collecting um,
Books on
amazing
maths.
historical maths books as
Have you
well.
got any historical maths books yourself?
Um, Not really. I found one. Oh, I meant to get it out and remind myself what the title was, but I found one in the Oxfam bookshop in Oxford recently that was just sort of sitting there, and it was actually a book about the history of maths. And it's only from the 1960s or 70s or something like that, but I think that's the oldest maths book that I own.
Fair enough.
Um,
I might be able to beat you on that one then, because listeners will already know I've got a copy of Elements on my shelf up there. But just reaching up onto my bookshelf in front of me, I've got the Hydraulics and Mechanics of Fluids by E.H. Lewitt, which, as you can see, is an entirely dusty old tome from 1943. I also have on my desk this lovely red Shorter Intermediate Mechanics by Humphrey Topping, which I do use regularly for my teaching, and that's 1949. I love the old books about maths, mainly because they
I,
don't use SI units.
um, I I like I really like old books about maths, but I like old books about anything and new books about anything, and it's all just gets a little bit cluttered. I've got a facsimile edition of Oliver Burns' Euclid.
Ah, yes.
Have you seen that? Have you had
This
a
is the in color version, isn't it?
yes?
Oh, it's lovely.
It's absolutely beautiful, and it's such a nice. I really like it from a sort of a pedagogical point of view. You know, as a maths teacher, as I know you are as well. Um, it's just another way of looking at the topics and themes involved. It's like basically the beginnings of geometry.
So to help the listener out, I think this is the 1800s copy, and it takes Euclid's work but replaces all of the Greek letters with color-coded angles. Is that right?
Yeah, yeah. There's not a lot of what you might think of as algebra in there. Um, it's all, you know, if these two angles are shaded in the same color, then they are the same size of angle. And it's just such a lovely, different way of thinking about the topic. And I think it's also like, what is it? I don't know, nearly 2000 years after the original work, and
Mm.
somebody is still not just making reprinting the same old thing, but they're taking this original work and thinking, oh, we can do something original with this. We can do something new with
Yeah.
this. And I think, is there any better way to demonstrate the longevity and importance of a historical text that thousands of years later someone is still making some version of it?
What I particularly love about that example is you don't get this game of whispers going on through the centuries and millennia. So I'm not going to say whether or not Jesus really said the stuff that we think he did in the Bible, but we know for a fact that Euclid said pretty much exactly the same because it was true then and it's still true now.
Yeah, I think that's an interesting rabbit hole to go down, I think we could probably do an entire episode on that idea, the idea that maths is true, whether you know about it or not. It's true for all time, and it's been true for all time, and it will remain true for all time. But the way we talk about it changes.
Mm.
And I think obviously Euclid wrote what Euclid wrote in a language that's very different to the main language that you and I use today. So I think we can sort of verify the things he said, but is it true that what we're writing today is exactly the same as what he wrote back then? I don't know.
Well, I suppose, yeah, the central message in the language and the diagrams and even the numbers are all different, but there is still an essence of truth that weaves through it. I want to talk about some books that aren't in my room though, or in your house, but some books that you've written about in your book. So, looking through the prehistory and the ancient history in the written record, there seems to be a period where authorship starts to become more commonly ascribed. Now, in this podcast series, we have been following the mathematicians whose names that we know. That's been quite an important part, and we begin with Ames and the papyrus that he wrote in ancient Egypt. But of course, in your book, chronicling the written record of mathematics, your story starts considerably earlier than Ames. So, could you give us a short summary of how you decided to begin your book? And I suppose another way of asking that same question is what really counts as a book of mathematics to go into your library?
I It's something I had in my head very early on. The concept of the book was given to me by the publisher. So it wasn't my idea. Someone came to me and said, actually, someone came to somebody else I know and said, would you like to write this book? And they said, I haven't got time at the moment, but I know a I know a guy who might be interested. Um, and they came to me and said, would you be interested in writing this book, part of a series of books on the same sort of theme, but each one is on a different subject. So there's one about astronomy, and there's one about atlases, and yeah, it's just looking at the books that have contributed to the development of those subjects throughout history, throughout human history. So I said, yeah, obviously, this sounds really good. This is right up my street. I'm really interested in this. And they said, we've done a little bit of research. We've got a list of books, and you're welcome to take that and just chuck it in the bin or add to it or take things off or whatever. But one of the things that I thought very, very early on was that I wanted to see how far back I could go. Like, how far back is the first example of humans writing mathematics in some sense? So I sort of went further back, and I thought, right, okay, once you get to some point, you've got to stretch the definition of book. And because you get so far, you get like the humans started writing books or printing books at this point in time, and then before that, if you're too strict about definition of book, you can't go any further back than that. So I thought, right, okay, if there's a written record somehow, I'm going to count it. So the very, very earliest thing that I've got in there is, I think the Lebombo bone from around 40,000 BC. So from my point of view, that counts as a book because it is a human being making a physical record of arguably some maths. And I think this is sort of widely thought of as being the earliest, uh, easily arguable mathematical object. Um, it's just a calf bone from an ancient relative of the modern baboon, discovered in a cave in the southern African Lubombo Mountains. And it's essentially just a piece of bone with some notches carved on it. And
And we think that's mathematics.
and with well, the I, I think it's generally accepted through historical writing, that this is someone counting something for some purpose. They're keeping track of how often something happens. And we will never ever know what that will be, but it seems to be fairly clear, I guess. Someone is keeping track of something repeating. And if you wanted a very, very basic definition of mathematics, then I guess it is sort of understanding things that repeat.
Yeah. So, I mean, 40,000 years BCE. This is my prehistory knowledge is very sparse. But am I right in thinking that this is what we think of as before common agriculture? So before sort of settled peoples where humanity was more tribal and in hunter-gatherer societies.
Yeah, I mean this is before any kind of written records. I think you've got some ancient wall and cave paintings that are a little bit older, but other than that, there's no real records of life. This is before written language develops, anything like that.
But we have notches that indicate some kind of progressive counting. Do we have an idea of how much it was counting up to, or are there intervals that it's counting in?
I get always get mixed up between the Lubombo bone and the Ishango bone, which is a mere 20,000 years old.
Yes.
There's 20,000 years between them, but I get mixed up between the two. And I think there's sort of 20, 27, 28, 29-ish notches on the Lubombo bone. I know there are on the Ishango
So that
bone.
that feels like it's measuring the phase of the moon.
Very, very possibly. I think that seems to be one of the common interpretations is that
Yeah,
they're counting the days of the month, for a
quite
month that was slightly longer back then.
quite possibly a menstrual cycle.
Again, that is one of the possibilities, an interesting possibility. I guess think in the context of modern conversations about certainly in schools and education where we're trying to get women and girls more interested in mathematics because uh, they're not very well represented. They're better represented these days than they have been in the last sort of 20 years or so, I think. But there's still some way to go. And to think like 40,000 years ago, the sort of little spark that set off mathematical thinking in the human race, that was um, um, a person counting their own menstrual cycles. So
Yeah. I mean, so listeners to the show will know that I'm expecting a baby any day now, and I do mean literally any day at the point of recording this. And we were told when the due date was going to be about 7 months ago, based on measuring or something to do with the sonogram. I don't really know. But the length of a gestational cycle has been relatively constant in humans for that long, and it's possibly one of the most important things you might ever want to know if you were planning
mm,
some kind of hunter-gatherer, tribal or nomadic society, is when you might suddenly need to stop for a period of 3 days and do something really important. So yeah, quite possibly, maybe that is one of the big motivators to start counting early on. I guess though it's an open mystery that we'll never really know for certain. Now, in your book, the Mathematicians Library, there is of course a wealth of written information, but a lot of the beauty and certainly the enjoyment that I got as a reader is the collection of the beautiful pictures that you have, the pictures of the mathematical works and indeed objects, as they are of course not all books. So a listener to the show won't have it in front of them like you and I do, and until they have gone and bought their own copy, could you give us an idea of what we might see looking at an old piece of a mathematical book? Just paint us a picture, a visual image of what does a truly ancient book really look like? Because it's not going to be printed, because that's not till the Gutenberg presses. It's not going to be bound. What is an old book?
Well, I think there's an enormous variety. Um, so obviously we've started off with a bone with scratches on it. That's a book in my
Just a
book,
single
literally.
page, more of a pamphlet, isn't it?
Yes, yes. And then I guess if we move to ancient Egypt, which is a time that you've covered, um, you've got quite a variety there actually as well. I think you've got some um, sort of very sort of pictorial diagram driven questions and things. Um,
So
but
I think we all know from school that in ancient Egypt they wrote on papyrus, and I'm not sure
yeah,
if everyone really knows what that actually looks like, but we
this
all have
sort of
an
lovely
image.
yellow textured um doesn't bend very well, I don't think. Certainly doesn't not now.
So are
And
these
it's
going to
sort
be
of
sort of rolled up in scrolls that are like tied up with a little bit of ribbon?
well, I'm not really sure. I mean, obviously the ones that we can see these days are sort of scraps with all jaggedy edges and you see bits and pieces. Like you've looked at the Ames papyrus,
Hmm.
and I think that is I think they've got the main body of that at the British Museum, but it's not on show at the moment, unfortunately. And that's sort of like it's a few meters long, and I think it's 30, 40 centimeters tall. And
Right.
so I think that would have originally been a rolled up thing, but just sort of this expanse of papyrus that has been drawn on. And of course, it's the writing on it. I think we quite often have a view in your mind of ancient Egyptian writing as all being hieroglyphics. But obviously, on the Ames papyrus, they use the hieratic script, so it's I think possibly more recognizable as writing than ancient Egyptian hieroglyphics might be to a lot of people. So it's less pictorial. It looks more like we might understand as writing. Um, and I think if we sort of shift geographically slightly over to
Yeah.
Mesopotamia.
What are they writing on? Yeah. What are they writing on in Persia and India and China?
Oh well, Persia, India, and China. I think they're using a a sort of paper, an early paper. I'm not entirely sure. Um, but they sort of 1100 BCE, I think, in China, you start to see things that look a lot like you would imagine a book to look like today, sort of um, pages of paper-like material being written on diagrams and things. But I think something which often isn't put in this context quite a lot, when we're talking about early mathematical writing, we kind of forget about the clay tablets of ancient Mesopotamia. And they're like clay tablets. Modern digital tablets are named after this sort of thing, right? They're sort of rectangular slabs. And in fact, I think there's a really famous one that I do mention in my book, the Plimpton 322, which I think it is about the size. If you've got like three or four iPads and sort of stack them on top of each other on a table, that's about the size of Plimpton 322,
Well, they're
except
very backwards compatible, aren't they?
it's yeah, it's made, and you would actually like we do today for a lot of writing on tablets, you'd use a stylus. And the stylus back then wasn't, it was a bit more universal, I think. It wasn't electronic, it didn't need charging. It was a stick, a little wooden stick, or possibly a bone stick with
They
a
wouldn't have been magnetically attached.
no, unlikely, and it had a little wedge tip on the end, and they would press this wedge tip into the clay in slightly different orientations to make different marks, and those marks meant different things. And just to sort of keep the spreadsheet, just keep the tablet analogy going forward. which is quite easy with Plimpton 322X. It is essentially a spreadsheet. It's got columns, numbers laid out in columns, and there's column headings across the top, and then down the side, I think down the right hand side actually, there's row headings, literally the numbers 1 to 15 or 16, I think, sort of labeling each row. And it does seem to be a lookup table for some trigonometric values, just relating to what we'd call today Pythagoras' theorem. I think this is something like 300 years before Pythagoras was supposed to have been born. So I do like that. So that I think it's important not to miss out things like clay tablets as historical books in inverted commas, because we're being very, very fast and loose with our definition of books here. So yeah, what do historical books look like? All sorts of things. They just used to write on anything, and found interesting ways of writing, from using ink to prodding a stick into clay.
Brilliant.
So I don't think there is a typical historical maths book.
No, we like that. No mode. They are all beautiful and unique objects. I suppose you'll have to go and buy the book to have a look at each of them.
I think this is one of the things that actually makes it worth making a nice picture heavy coffee table book about mathematics. Is there's tons, especially the early ones, each of the early things, they all look very different. So it's not just page after page of algebra.
It's exactly why I asked you to come on for an audio only podcast.
I know it's a wonderfully visual book for a podcast, isn't it?
Okay, so going back to the authors then, because that's more the things that I'm interested in. Now, I've been breaking down the early history into series that vaguely follow the Mediterranean tradition, the Indian Persian tradition, and then later we'll do the Chinese tradition in sort of largely compartmentalized spheres, because as far as I'm aware, there's not all that much crossover until a little bit later. In each of these traditions, could you give us a sense in sort of when in history it starts to become more common to have a prominent mathematician rather than a prominent work of mathematics? So, in other words, when did the authors start writing down their names next to the work as a commonplace thing?
I'm going to give a guarded I don't know, first of all, and then talk in slightly more detail around that question, I think.
Okay, yeah, that's good.
Because I'm not really sure. And I think I want to sort of jump tracks on that one a bit and talk about the sort of reverence that we apply to specific named mathematicians. And that I want to say that I don't think it's the best thing for mathematics in terms of a sort of modern attitudes to maths, societal attitudes to maths, and maths education. And I think we need to make movements towards making it a bit more about the maths than it is about the mathematician. And I know I'm saying that your podcast is structured around specific mathematicians, and I think there is a place to be looking at specific mathematicians and digging out what they did. And I think you do a really good job of this, because you're quite clear when there are things ascribed to mathematicians specifically, but actually there's a lot of stuff that goes on in the background. I think like the archetypal famous saying is, I think it's attributed to Newton, that he said something like,
I can only see so far because I can stand on the shoulders of giants. Yeah.
If I've seen further, it's because I'm standing on the shoulders of giants. And I think that is important to remember about mathematics. I think one of the issues that we have with mathematics in education today and in society as a whole, with regards to attitudes towards the subject, is that it's like, I can't do mathematics because I wasn't born with that gene that Euclid had, or Pythagoras, or Newton, or Einstein, or I haven't got whatever gene that was that allows me to know all of algebra in my brain from birth. And I think that's a problem with the view of mathematics today, that it's only certain people that can do it, when in reality, like, the people that have their name on things, in a lot of cases, they're not the person that did it. But even if they are the person that did it, they put the full stop on the end, and they built on top of lots of other people's work. And I don't mean that to sound like I want to diminish the achievements of people that have sort of put the icing on that particular mathematical cake, because that's an achievement in itself. But reducing it to one name, one person's name, it forgets, it erases all the work that's gone before. And this is mathematics is not something that is lots of things that very clever individuals have found out by themselves, locked in a room with a pencil and a piece of paper and a timer. It's a work of communities and civilizations throughout history. Um, and I think like a really good example of this is Pythagoras, because Pythagoras is one of those individuals, like probably the only mathematician that most people, certainly most people in the UK, I think, go through school having heard their name, and they go, is the only mathematician that people know the name of. But there's a dispute as to whether it was actually the name of a mathematician. Like, did Pythagoras actually exist? There's some theories about Jesus that a lot of the things that are ascribed to Jesus are actually done by lots of different people, and then in legend they've been sort of combined together in one person. There's theories like this about James Bond as well. Like
Yeah.
the James Bonds change every now and then because they're actually different people, but they've sort of been bunched together as one set of stories. I know James Bond's not real, by the way. Um, but there's some ideas that Pythagoras could have been stuff that's ascribed to Pythagoras could have been stuff that's done by lots of different people and then sort of bunched together.
Well, I
And I
mean,
heard,
we've definitely looked at quite a lot of the school of the Pythagoreans, and
yes,
there's been
yeah.
about 12 people on the show that we've covered so far that all get lumped together underneath Pythagoras. But
I,
even
I,
then, we don't
I
know if they individually made any contribution.
absolutely. I was at a history of maths event a few months ago, and someone said something like, it's possibly not likely, but it's entirely possible that Pythagoras was the name of a bakery or a bar or something that where a bunch of people used to meet and do maths regularly, and they sort of this theorem was written at Pythagoras's bar, and it became Pythagoras's theorem over history, and it could be that
So,
I love that idea.
so for listeners who are thinking that that sounds too outlandish, I should point out that this is something that has actually happened in recent history that we know has happened with Nicholas Bourbaki, who
Yeah,
we haven't covered and probably will never cover because he wasn't real. He was instead a group of what's it, about 10 or 12 math students.
that used to write collectively
Yeah,
under the name Nicholas Bourbaki. Yeah,
yeah.
it's got. I was going to say it's got a modern precedent. I
Modern
don't think
ish.
that's quite the phrase I mean, because can you have a modern precedent for something that
Well,
happened in ancient history? But I don't know.
so
But absolutely, and also like uh, just not wanting to beat on Pythagoras too much. It's not his fault. But again, we know his name because we've heard his name through our education system as we've grown up. Pythagoras,
self-reinforcing.
the most famous mathematician, and he's famous for Pythagoras' theorem, which is that theorem which says that if you square the two lengths of two short sides of a right angled triangle, you get the same as if you square the long side of a right angled triangle. And but the ancient Babylonians knew that fact
Mm,
300 years before Pythagoras was said to exist.
yeah,
So it's why is it named after Pythagoras? Is it named after Pythagoras because he made that particular, if we assume that Pythagoras was an actual person, was it named after him because he made that particular discovery, because he was the first to make that discovery? Was it named after him because he happened to be the first guy to write it down? Or is it named after him through sort of a complete magic of history and luck that he wrote it down and it's his version of it that was written down has managed to survive? Um, and I think that to me leads to the question of whether we should be naming important mathematical theorems and things after people. Because I don't know about you, but I've met lots of kids in schools as a teacher, and when you talk about Pythagoras' theorem, and they're like, don't know, no idea what this is to do with or anything, even though I've been taught it every year for the past 4 years. But I feel like if we called it the right angle triangle theorem or something like that, they'd go at least, oh yeah, it's that one. So
Indeed.
is it
I
even
I don't
useful to name things after mathematicians? Don't know.
I don't disagree with you that we should be underemphasizing the mathematicians themselves, and I am well aware of the irony that it's me saying that. For long-time listeners of the show, you'll notice that my recent running joke is about all the conferences that I've attended. But in truth, Tom and I actually met at a conference where we were both sitting in a seminar about this very concept of should we give credit to mathematicians, and that was 6 months after I started the show, and inside I was thinking, damn. Back to the wrong horse. But so since then, I've been trying to emphasize more the group nature of understanding, and really just using the names of people as a jumping off point for following the history more
Yeah,
broadly.
I think
You
that's important. Like with my book, so I've done a similar thing. The names of the books that I'm exploring are the structure in there, but actually I'm trying to explore broader stories around those sort of hinge points, I guess. And that's what you're doing with the Mathematicians podcast. It's not
Well,
about
hopefully, I like to think
yeah.
last time, which hasn't yet been released because we're recording in the past. The last time we did the episode on Umaswati and the 800 years of Jaina mathematical tradition. That we don't really know the names of the people that actually came up with the ideas, so it all kind of gets bundled under Umaswati. But we still get to talk about how it was a collective effort and try to give some credit where it's due to the large number of people, the succession of giants that he stood upon. Um, okay, lovely. So let's pick a new question then. Earlier in the series of these injectives, we had a guest, Dr. Peter Adamson, talking to us about ancient Greek philosophers, and he told the story of the extant written record of Euclid's Elements, told through the various translations and transcriptions, and followed that one book coming through to how it sits on my bookshelf today. I was galled to find out that I don't actually have an original copy. I was wondering if there is a similar story of a mathematical book or broader mathematical idea that you think has a particularly interesting journey as it's travelled from author down the ages to the present day. Are there any stories or ideas that you particularly like?
Yeah, I mean there's the famous story of Fermat's last theorem, which even if you don't know what the story is, I think most people have heard that phrase,
Right up
Fermat's
there with
last theorem.
Pythagoras' theorem, the two theorems that we know.
Yeah, exactly. Now, I think Fermat's last theorem is named after a mathematician called Pierre de Fermat. Um, and I think this is based on something he wrote in 1650. I think I've got the right thing there, 1650. Um, but the book he wrote it in is a book from much longer ago.
So you're saying he didn't
It's
write it in a fresh book, he wrote it on top of a pre-existing book.
yeah. So he had a pre-existing book, and I'm just flicking through my book here just to try. I can't remember the dates. I'm not very good with numbers. Um, uh, so I'm trying to.
Whilst you're doing that, I'll help you with some background waffle. So I mentioned it's up there with Pythagoras' theorem. I think I'm not too far off with that joke because if I recall, the theorem says a squared plus b squared equals c squared. That's Pythagoras. But then if we do Fermat's theorem, is it a to the power of n plus b to the power of n is c to the power of n? And then we want to find that's true for a particular value of n. So sort of a generalized version.
Yeah. Um, I think, sorry, I wasn't listening entirely while doing that because I was just flicking through. I think I found the right place in my book now. But yeah, so Fermat's note in the margin was basically like, I've got a proof for this special case of this problem, but there's not enough space in the margin for me to write the proof. And then this note isn't discovered until after he's died. I think his brother or someone is looking through his old books, clearing out his house, and finds this margin note, but can't find anything where he might have written this. So nobody knows if he actually did write down a proof for it, or if he just said, "I've got a proof." Maybe he's having to think about something. And he thought, "Yeah, I know how to do that, but I haven't got space at the moment." And then maybe didn't come back to it, or wrote it down somewhere and it was lost.
Mm.
But the book he was writing in is um a a later published version of a book from 250 ACE, right? So this is early enough in the modern era that it only has 3 digits in the year. So this is a book called Arithmetica, written by Diophantus. Um, uh, and I think that the version Fermat was writing in would have been quite a different version of the book, because it would have been in a different language for starters, but essentially the same kind of thing. Like we were talking about earlier with Euclid being sort of translated over the years. I think when people translate a book, um, I've included a number of translations as important works in my books, because I think when people translate a book, they don't just change it from one language to another. They sort of add some interpretation in there, and I think it's unavoidable that that happens. But there's a number of translations in the mathematical sphere where some people have, in their notes that they add while they're translating, they sort of, in some cases, the notes, there's more in the notes than there are in the original work in the
The
first place.
commentary, and I think you might say exegesis. Is that the phrase?
I guess, yes, that sort of thing. So I think it's quite often to sort of, it's quite easy to dismiss something as just a translation. But actually, I don't think there's any such thing, because I think somebody has to not only understand the languages, both languages, the one they're translating from and to, really, really well, they have to understand the subject matter really, really well. And I
Mm.
think it's going to be unavoidable that you might add something in that process of translation. I mean, I guess like a very well-known example of that is with Ada Lovelace translating, was it Manabria's work on the analytical engine? And Ada Lovelace's notes take up more space than her translation does. And in her notes, in one of her notes, she actually writes what is widely thought of as being the world's first computer program, without a computer to run it on. It's something that would run on the analytical engine if it was completed. And that's inarguably an an important addition to the thing that she's translating. But anyway, so Fermat's got a later copy of Diophantus's Arithmetica, which was like a 13-book volume of numerical problems and solutions. I think only 6 have survived
And
through to
these are the
today.
problems. These are the problems where you need to find an integer solution as well, aren't they? You have to have whole number answers only to make it a Diophantine equation.
Yes, yeah. And so Fermat's looking through this book, and one of those problems he's thinking, oh, I think I can, if I can uh, understand this particular problem, a special case of this problem where if we have an integer n that is greater than 2, then a to the n plus b to the n equals c to the n has no solutions for a, b, and c, a, b, and c being non-zero. Um, and then he thinks, yep, okay. This is a special case of something that Diophantus has written, and I think I can probably prove that, and writes down that he has managed to prove it in the margin, and then nobody ever finds this. In fact, they don't find his margin note until after he's died. And then this becomes a problem that mathematicians are working on over the next few centuries. So this is 1650. He writes his margin note thereabouts. And throughout history, there's various mathematicians jumping on and partially solving, or thinking they've solved and then not actually solving Fermat's last theorem or bits of his last theorem. So I think, was it Sophie Germain? I think at some point, I think it was Sophie Germain. Um, in 1820 something, I think it was her, solved proved Fermat's last theorem. Yeah, proved Fermat's last theorem for the specific case where n equals 5, so where that power is 5. So she solved that in a footnote of a mathematician Legendre's book. So this is a book that
Can
another
mathematicians just
mathematician
not
has
afford their
written,
own paper?
and she's had a footnote published in his book, which proves this particular case of Fermat's last theorem. So this mathematician's trying to solve Fermat's last theorem for hundreds of years. Eventually, it gets solved in 1995 by Andrew Wiles at Oxford Uni. And he's done, I think he just done an enormous amount of work on this, and I think it originally published his proof, or initially announced his proof in 1993. People were checking it through and found an error, which must be a big a big kick in various body
Oh,
parts, I think.
yeah.
And then he spends another 2 years correcting that error and published a version in 1995, which is true, which works. And
And all of
it,
this is
I
just to prove that it's not possible to do.
yeah, this is just
That's so
yeah, yes.
tedious, isn't it?
Where this thing that you've said is not possible is actually possible, is actually not possible, and we've proven that now. We know it's not possible, and here's why. And that is, what did I say? Diophantus's book was 250 CE, and it's finally solved in 1995. Like, this is nearly 2,000 years on one problem.
So if we were to fast forward another 1,000 years, who do you think is going to be revered as a more significant contributor? Diophantus, who originally, let's say, created the format of integer solution arithmetic. Fermat, who originally devised the problem of the Fermat's last theorem, or Wiles, who eventually solved and finished gave the solution for it.
Well, I mean, I think we can look at who's most well known right now. Like,
Diophantus, right?
what I mean, I would say Fermat is the more famous one. I mean, I'd say he's probably had more books and more well-known books written from him. I don't know, like, the main book I can think of is Simon Singh's Fermat's Last Theorem book. And I don't know if that's affecting why I think Fermat is the more famous, sort of broadly speaking. I think amongst mathematicians and historians of maths and people who are interested in history of maths, maybe Diophantus is more well known. I don't know, but I think sort of out in general society, if you say the names Diophantus, Fermat, and Andrew Wiles, the one that people are going to recognize more often is Fermat, I'm sure. Even if you don't know what it's about, that name is quite widely recognized, I would imagine. And I'd say that probably the least recognized of them all is Andrew Wiles. So maybe in 1,000 years' time, if there is a name still attached to this thing,
Well, if there is
would
a
it
thousand
still be
years time.
Fermat?
Sure. Well, it's an interesting question though, and certainly in the context of should we be associating names with mathematics or not? It's an interesting question to ask. Who, if you are going to associate a name, which name is the one that deserves it, I suppose. But clearly, they all contributed a hell of a lot to the field. Uh, well, that's been a bit heavy so far. Let's see if we can try a slightly lighter question, shall we? So, for listeners of UK radio, my next question is going to be an obvious one. I would like you to imagine that you are going to a deserted island and you get to bring one ancient document with you to spend your time studying. Let's imagine you can speak the language and read the script as well. So, for listeners at home, we're playing Desert Island Codex. What mathematical text would you like to have an original copy of?
That's such a hard question. That's just a really hard
You've
question.
only had a week to prepare for it as well.
I know, and I've struggled. I think it's a boring answer, but I might go for um, Oliver Burns' Euclid, just because it's such a beautiful book. It's just gorgeous, and it's just even if I haven't got the brain space at some point to sit down and go through the maths, I can just sit and look through the pages and go, oh, that's lovely. That looks really nice. I think it's a book that works on many levels, from sort of like this is a very pretty book, down to this has some important truths about the very universe we exist in. So I don't know. Is that too boring an answer?
It's a perfectly valid answer. It is sadly the wrong answer because I do have the correct answer here, which I happened to buy this book last week, and it has just captivated me since. This is a book of maths games by Ben Orlin, and that has been keeping me entertained all week. Games you can
I
play in the sand.
I've seen you post about it, and I haven't read it, but I am aware of it, and it looks like a great book, and I do want a copy.
Okay, so follow-up question to Desert Island Codex. If there is because a lot of the work of mathematics is not written down, it's an oral tradition of wisdom passed from one person to another. So can we play Desert Island Dicta? Is there an ancient lecture or recital that you would love to be in the audience and listen to?
Um, I think if I was in like an ancient recital or something, even language barriers notwithstanding, I think I would probably to struggle to understand a lot of them. Um, but I think rather than and I'm doing this thing again where I'm changing your question, sorry.
No,
Rather
it's just you,
than
you you made me think about some of my lectures that I went to at university. I'd quite like to go back and see if I can finally understand what a tensor is.
I know what you mean.
Yeah, sorry, go on.
I'm with you there. I think I'm more likely than sitting through a lecture, I'm more likely to want to sit in on muscle my way into the pub trip afterwards, and have a conversation with them about like what got them interested in that topic in the first place. What pushed them down that route, why they thought it was interesting, why they thought it's useful, where it might be applied in the future. I imagine there's a lot of conversations like that can never interesting stuff that can come out of conversations like that would never ever come out of a lecture. Um, and I still haven't mentioned the name of a person, but basically, like anyone that I've come across in my book would be good. I thought Kepler sounded like he might be a really interesting person.
Yeah, yeah, definitely.
Um, so
Okay,
yeah,
that's
I've
good.
changed it into who do you want to have a chat with in a pub?
You can bring a person to your desert island. I don't have a desert island discs pun based on a person, sadly. I didn't plan ahead, but you can write your comments at the bottom of the podcast. So looking at the wider corpus of mathematical literature, was there a work of mathematics that we know existed because of the references to it, but no copy of the original has survived, and therefore it's missing from your book? I suppose is there something that you were hoping that you could write about because of the rumor or the record or the implication that's there, but we just don't have?
I think again, I've had a week to prepare for this question, and actually things have taken over me. And I was going to look up because I'm pretty sure I remember writing about some of these books where we are aware of the book's existence because other people later in history have written about that book, or they've written a version of that book, but people aren't quite sure who wrote the first version. They know it's we're aware that the extant versions that we have are tribute acts to an original work that's been lost to time. And I don't think that's particularly rare. Having said that, I can't come up with a concrete example. But again, like I've not come at this with thinking too much about who the authors actually are. I've sort of come at this as are there any interesting stories surrounding this publication? What's the publication's position in the history of mathematics, rather than what's the important about the author, about the person in the on the title page. So I can't give you any specific examples of that, but I'm pretty sure that if you read the book all the way through, you'll find some.
Fair enough. I tried to come up with answers to most of my own questions myself, just to make sure that it's an answerable question. Classic school teacher habit. But some of the
Yeah.
ones that I might have been thinking about were certainly until about 100 years ago. The method from Archimedes, I think, was something that we knew must have existed because the method is then applied everywhere. But it took a long time to find an original copy from the palimpsest.
Mm.
Palimpsest. Um, or another example that I think is an interesting one, low-key conspiracy alert, but I'm pretty sure the FBI has stolen Nikolai Tesla's notes when he died because he was a genius, didn't leave any written material after his death.
Oh, he's supposed to have invented all sorts of things that have
Oh,
since
everything.
the plans have disappeared.
Yeah,
Um,
well,
but
they have been disappeared. Yeah.
yeah, they have been disappeared. Yeah, they have. Yeah, they should be around, but not. I think he sounds like a fascinating individual. I think actually, slightly more possibly helpful answer, sort of slightly tangential to your question, might be if we look at because I know you covered Ames's papyrus quite early on, and um, through a large a part of sort of contemporary history, at least, the Ames papyrus has been known more commonly as the Rind papyrus,
Mm,
and I think that you have probably made the decision to call it the Ames papyrus the same reason I did.
not originally, but since.
Because like the Rind, but as the Rind papyrus, Henry Rind was a archaeologist who bought it from someone who liberated it, maybe from a ruin. And does that person deserve to have their name attached to it more strongly than the person written who has their name written on it as being the scribe? And I would argue no, the person who's got their name on it, it deserves it a bit more. But also that we don't really know where the scribe was coming from in writing this stuff down. I mean, was it their original work? I think possibly not. Were they copying out an older document? That's a possibility. In which case, like the Ames Papyrus might be an example that you're talking of, where actually we don't know who wrote that stuff originally. It seems to be, I think, if I've got the right end of the stick here, it seems to be a collection of um, questions and results from mathematics that are probably much older than the version of the papyrus that we've had access to.
Mm, yeah, no,
So,
definitely. I
who was the original author of that?
well,
Um,
I think we are relatively confident that he was referencing work that was at least about 1,000 years older than himself, but it's
exactly. So,
largely
so,
speculative, isn't it?
and was there anything in there where he did add something to it? I mean, that would be quite interesting as well. We don't know. Like, is there anything in there that was his own original work? Who put his own spin on something?
Hmm.
Um,
Do we
or
even know
was
that his name was Ames, or possibly her name was Ames, or maybe that was just someone that they were going to go have lunch with later today, and they just scribbled that as a memento? Who
um,
knows?
exactly as it could be a Nicholas Bourbaki type thing? We've got this group of scribes that we just call Ames.
Yeah, yeah,
Um,
yeah, maybe. So let's move away from books because Tom has primarily been invited to the show as an expert in mathematical texts, but this book is not your day job. As I understand it, your main work these days is working with museums to help improve their understanding of the mathematics of their own collections. So, for instance, you might go to a car museum with content on fluid dynamics, or a mining museum with calculations on energy density and power, or that kind of thing. Is that right?
yes. Yeah, I like to call myself a math communicator and museum learning consultant,
Mm.
because that's nicely vague.
So one of your first assignments working as a museums enrichment consultant in maths, I believe you were working for Bletchley Park, which for international listeners, this was the HQ of British military intelligence, the team that cracked the Enigma codes during World War II. You can go and watch The Imitation Game. Not exactly informative, but it's a pretty cool film that vaguely relates to it. On the topics of coding and encryptions and secrets, could you tell us a little bit about some of the ways and means in history or in ancient times where leaders or generals might have sent messages without fear of interception? So, what do you see as the origins of encryption?
Well, I think there's quite a broad range of things that could be considered as encryption. So you've got, I think, probably the first thing that comes into most people's heads is where you have a message and you do something to change that message so that it looks like gibberish, and then send that message. And then at the other end, they know how to change it back into the original message. But there's other processes that people have used in the past as well, which is about physically hiding the existence of a message. So the message is perfectly easy to read, but only if you know it's there in the first place. So I think an example of this that I used to use when I was visiting schools on this topic was the idea of using a slave, which obviously I don't support this method now, um, but they would.
I think that needs to be said. Thank you for taking a strong stance.
They would, they would get a slave from their ranks of slaves. They would shave the slave's head. They'd tattoo their message onto the back of the slave's head, and then they would let the hair grow back a bit, and then they'd send the slave with a much more innocuous message in their pocket, I think, so that if they got captured, it's like, hey, this unimportant message here, and then when they get to where the message needs to go, the person at that end knows that they need to shave the slave's head, and they can read the message off it. So it may be not encrypted in a sense that a lot of people would think of that word these days, but sort of hiding messages is kind of important as well. I think that there's another one. Again, I haven't looked into this for quite a while, but I remember there was something about tablets, this time not clay tablets, but wooden tablets with wax on the top, so a coating of wax, and you'd use a stylus to scratch notes, messages, whatever, into the wax on the surface of the tablet. And this was sort of a normal method of communication. And there's a story about is some of these tablets having the wax cleared off them completely and having a message scratched into the wood itself, and then it's covered over with wax, which obscures the message. So when this shipment of tablets gets to wherever it needs to go, somebody picks them up and then knows to scrape all the wax off so they can see the actual message on the wood. So sort of another sort of obscuring that a message exists in the first place.
Do we have
I,
any good early examples of the more gibberish version? So using some kind of
yeah.
cipher?
I think the classic example is the Caesar cipher, named after Julius Caesar. I think in Julius Caesar's time, merely writing a message down was an act of encryption because most of his enemies were illiterate anyway at that time. They couldn't read anything, but
Well, they
in
didn't
order
go
to,
to the right schools to speak
yeah,
Latin, did they?
well, exactly. In a an effort to make it even more difficult to read, you can take each letter of your message and swap it for one, two, three, four spaces up the alphabet, and then when the person receives that message, it looks like gibberish, but if it's the right person, they know what you've done, so they can undo it by swapping each letter they've received by the one, two, three, or four spaces down the alphabet. And that's probably like the first encryption method that most people learn if they learn about encryption at all these days, the Caesar cipher.
Do you think
And
that deserved a place in a book on mathematical texts, or do you think that doesn't constitute early mathematics?
good question. I I didn't deem it worthy of inclusion in my book, partly because if I'd found a book that um an early book that did a mathematical treatment of early encryption, I think I'd probably be interested in that. And if anybody is listening and is thinking, well, why didn't you put this one in? Duh, I would be interested to hear about that one because I can't think of one off the top of my head at the moment. But
So you're
um,
saying if anyone wants to hire an author for the Computer Scientists Library, you're available.
yeah, go for it. That would be great. I really, really enjoyed doing the research and writing for this book, so I'd love to do another one. I really would. It was fantastic. It's great fun.
Okay, so moving away from encryption and off to the world of museums more generally, One area that we've bumped into the show more recently is the Babylonian tablets. You've talked about them before earlier in this interview. As I understand it, there's something between 500,000 and 2 million of these in various musea and universities out there in the world that we know of. And I think the British Museum has the largest single collection. One hopes that these are only the tablets that were buried in Kent and that they didn't steal them from anywhere. But as I understand that only under about 100,000 tablets have actually been read. So, how confident do you think we can be about the position of mathematical understanding in ancient Mesopotamia, when we know that there is still so much source material to check?
I think we could, if I zoom out a bit and think about sort of written mathematical material in general, not necessarily keeping it to clay tablets. If we think about the number of works of mathematics which must have been written, and compare that to the number of mathematical texts that we have available to us and that have been read and understood and analyzed, we could ask a similar question. The main difference being that we know there must be a ton of books that we will never have access to, we can't read. Yet we still view these items historically and try to build up a picture of how mathematics has developed throughout history. And I think that is something that applies to the clay tablets thing as well. Yeah, there's a lot of them that we've not been through yet and haven't contributed to historical understanding of the development of mathematics in that sort of more focused part of history. And I think the only thing we can do is analyze what we've got, and then if we look through some other stuff at a later date and it contradicts what we've said, we change what we say. We change our views to fit the facts as more facts emerge. And I think that is how we do maths and how we do science and how we do history in general, isn't it? There's always going to be holes, even if we've read everything that we have access to. There's going to be stuff that we will never have access to. So there will always be holes. We've just got to do the best we can with what we've managed to do so far. Does that make
Sure.
sense?
Yeah, I mean, knowing some of the mathematical friends that you and I have in common, I'm always nervous when someone mentions there being holes and counting how many holes there are. But I get your overall point.
How
I
many holes in a
suppose,
straw?
well, exactly. I suppose it's not likely that there's a secret Nikola Tesla equivalent character in ancient Babylonia who might have developed mathematics so much further and then been completely wiped off the map. So we can get a general sense of what they probably knew based on what was around them, even if we haven't read through all of their source material. That's yeah, that makes sense. So, looking at the landscape of museums that you have worked with, are you able to point us towards any particular museum in the UK that you think has done an excellent job at discovering their mathematics? And I'm maybe thinking about one where maths isn't the primary focus of what it is they do.
I think that you're telling me not to go to say Maths World and Math City,
Yeah,
aren't you?
Maths World, Math City, excellent. The National Science Museum, excellent. But outside of math and science, yeah, who do you think is doing a really good job at developing their maths provision?
I think at the moment the answer is nobody. That sounds like I'm being really negative. I think I'm going to try and make it not sound so negative. I think
Presumably, some of the people that have hired you are doing better since.
there's some bits and bobs out there that where people have hired me and then I've created some stuff and then left it behind and hopefully it's a little bit more mathematical than it was before. But I think in modern society, certainly Western society, and specifically obviously British society, because that's where I'm based. So I know more about British society than other societies around the world at the moment. But I think that the habit across society, not just in museums, is to hide mathematics and hide from mathematics rather than leaping into it gleefully and trying to see what you can find out. I think there seems to be a movement towards museums and galleries being a little bit more open to recognizing their mathematical stories that they have, because um, I just seem to be getting gradually more work on that front, which is what makes me feel that people are more open to it. And um, uh, yeah, I can point to the Bank of sorry, the Bank of England Museum. I didn't realize that phrase was so hard to say. The Bank of England Museum, they commissioned me to do some work a few years ago for an exhibition, which I believe is still there, called The Future of Money. It's an interesting little exhibition, and a lot of people I talk to don't realize that the Bank of England has a museum. So, I think it's quite nice to point this one out. It's in central London, in the bank area, of course. Um, um, so they recognize that there was a mathematical story being woven through the history of money, and they wanted to explore that with some schools resources. So that was really nice, and they got in touch about that. I've done a little bit of work recently. I don't know if the resources have gone online yet, for the NCAP, the National Collection of Aerial Photography, who are online. They don't have a physical site that you can go and visit, but they have a massive collection of aerial photography, a subset of which is based in World War II aerial reconnaissance and involved in some Secret Service operations and analysed by the folks at RAF Medmenham, who did a lot of mathematical work on these obviously two-dimensional photographs to find out three-dimensional information and decide various things there. So I know they are looking on the mathematical side of things as well. I'm looking forward to those being released. That should be fun. You mentioned the National Science Museum. They obviously have a mathematics gallery. I have lots of comments about the mathematics gallery there. I think it's great that they have a mathematics gallery, but I would love to see the mathematics in all the other galleries that are not labeled mathematics galleries explored a little bit more deeply, because there are stories in there. And I think that's really where we need to go, is not creating separate maths things in museums and for museums, but looking at the stories they're already telling and saying, right, so where's the maths that's bubbling away just below the surface there? And how can we bring that maths up to the top to help people see, oh, hang on, yeah, this is not just a history story, but it's also a maths story. This is not just a computing story, but it's also a maths story. This is not just a geography story, it's also a maths story. I think that's where I'm trying to encourage people to go in the heritage sector at the moment. And it seems to be moving in that direction slowly.
Yeah, well, I mean, it's so one of my new hobbies since meeting you is when I go to museums, mostly with my daughter, is to try to find the elements of maths that is either there and present or missing, and send you a photo of it, which I'm sure makes you go, oh yes, thanks, Ben, that's very good.
No, no, not
But
at all. I really enjoy it. I really enjoy it. And more than that, I want to jump in there and just say, anybody listening to this who feels like they would want to do such a thing as well, please do. Maybe not even necessarily just sending me a picture and doing something. What I'd really like to see is a few more posts popping up on social media, blog posts, maybe even a podcast, where people are saying, I've been to a museum and I found a mathematical story and these are my thoughts about it. I'd love to be sharing other people's thoughts on that rather than just chucking my own thoughts out there all the time.
okay. Okay, so let's go to some questions that I ask most of my guests. With your perspective as a mathematician yourself, someone who has studied the texts of history and mathematical writings, someone who works daily to discover mathematics in unlikely places in musea, what do you think mathematics really is? And
I'm
before you go into a nice long answer,
okay.
I'm really looking for a pithy soundbite rather than anything professional or serious. What do you think mathematics is?
Um, pithy soundbite. I've been trying to come up with a pithy soundbite for this for ages, and I just failed dismally because I mean, my only real honest answer is I have no idea. And I think that's because mathematics is just sort of everything, really. Um, but pithy soundbite,
I asked for
maybe.
mathematics, not geography. Geography is everything.
I mean, geography, you could argue that's a subset of mathematics. Um, yeah, so pithy soundbite, I would say it's the um study. No, what do I normally say? I can't remember what I normally say. I'm sorry, you're just gonna have to delete bits of this to fit it into the podcast. But um Maths is the exploration. No, sorry, say that again. Maths is the exploration of pattern.
All right,
Maybe that
that's
works.
that's good. No, I
Exploration of
like
pattern.
patterns. Yeah, definitely. I think of it as stuff that we know. The exploration of pattern makes it sound a bit more like a dynamic definition as opposed to a static definition of just stuff we know. Um,
Exploring, creating,
yeah. Well,
experimenting with patterns.
the whole Bloom's taxonomy on patterns. We got it. Okay, great. So, and then finally, a question for you is there a mathematician? And I know you don't like mathematicians by name, but is there a mathematician who you think would be most fun for me to talk about in the future? Is there a mathematician you might be looking forward to an episode coming out on?
I'm looking forward most to hearing about mathematicians that I don't know anything about already. Um, that's that's my main thing. I like to find out stuff I don't already know. I like to be introduced to something new, different.
Well, I will happily admit that I was introduced to a new mathematician reading your book, which is Pingala, who is absent from my database on mathematicians to cover. And so, even though it's now asynchronous, next week I am doing a special episode on Pingala to make sure he's in the mathematical record.
I think sort of generally thought of as being a poet rather than a mathematician.
Well,
Um,
spoiler alert, the entire episode is going to be a beat poem.
oh, lovely! I really look forward to that. That sounds mad. My kind of mad. But there are a lot of people in history, I think, who are not generally thought of as mathematicians, like Florence Nightingale, for example. She's known for doing some really good work, which boils down, I think, in a lot of cases to wandering around a hospital with a lamp. But she did a lot more than that. And I think probably her biggest contribution was the statistical work she did, but that's not spoken about very much, which I think
And
is a shame. So,
more than just inventing a pie chart or a Rose diagram, she also did
oh,
work on
absolutely.
pushing statistical evidence and arguing from a point of statistics. And
Absolutely. She was the
yeah,
first female member of the Royal Statistical Society, and I think that is something that is worth knowing more broadly. So I think, aside from mathematicians that I don't know much about, I would like to hear about the mathematical exploits of people who we don't think of as mathematicians in society a lot, but actually were. I think it's um, a very modern feeling that you're either a mathematician or you're a statistician or you're a physicist or you're a geographer or you're
or a
a sports
poet.
personality or a poet or something. Whereas if you start going back just more than a few hundred years, everybody's all of these things,
Yeah,
depending on
absolutely.
who's reading it.
Right. Well, that's all of my questions then. So, Tom, thank you so much for coming on the show. I can assure you it has been an absolute pleasure, and I also really enjoyed myself. So that's great. Before we say goodbye, can I give you an opportunity to talk about anything that you would like to talk about? So, what projects are you working on? Where can people find out more about you? How would you like to direct the audience's attention?
Okay, um, I have done a project in the last couple of years when I was still teaching part time with a research partner friend of mine who is just finishing off his PhD now. As part of his PhD, we did a project together where we experimented on some of my students. We did a half term's worth of teaching to the normal scheme of work, except we made a point of injecting history of maths content into every lesson throughout that half term. And we gave them a questionnaire at the beginning and the end of this period to test to gauge their feelings about maths and history in maths lessons and some other bits and bobs, to have a look at how their feelings about those things changed from the start to the end. And we also asked other students in their year group. We gave them the same questionnaire so that we could check that against the people in the experimental group. We've got a paper about that in peer review at the moment. Hopefully, it will be published at some point soon. I will let you know when it does come out. But as part of this project, during this project, we spoke to a lot of maths teachers and found that there was a lot of feeling that they would like to involve more history of maths in maths lessons, but they didn't have a lot of experience with history of maths because it's, not everybody does it even as part of an undergraduate maths degree, and it's even rarer to experience history of maths as part of a maths PGCE or any teacher training course, for example. Um, but I think the history of the subject is a really important part of any subject. Um, so we thought about how could we start to help overcome this issue, people being interested but not having a lot of experience. And we thought if we could find a way of bringing people together in a community, people who are interested in history, people who are interested in maths, people who are interested in education, and people who are interested in the intersections, the various possible intersections of all three things. If we can bring people together and sort of facilitate conversations, then maybe we can start to help make people more confident to talk about the history of mathematics, but also the other direction where mathematics turns up in history, and maybe get some history teachers starting to talk about maths in their lessons. That would be amazing too. So we thought we'd set up a network. We have a fledgling network called the History and Mathematics in Education Network. So far, it is an email mailing list with about 45 people on it, I think. I occasionally chuck stuff onto that mailing list that might be interesting on the history and maths side of things. We've got some people in there who are maths teachers, some are history teachers, some are working in museums, some are not sort of professionally involved in any of those things. They're just interested in history or maths or education. It would be great to have a few more people joining that list and starting to share things themselves. So it's not just me broadcasting things. That would be lovely. That's called the History and Mathematics in Education Network. And you can find some details about that at historyand.mathsy.space. Put that into your browser and you can find some information and join the mailing list.
Or click on the link in the description below.
Click on the link in the description below. Yes, I haven't done this podcasting thing much. Thank you very much.
That's all right. You can always slip in a link in the description. That's fine.
If anybody wants to get in touch with me about anything that they've heard today, or for any reason whatsoever, I'm always happy to hear from people as long as they're positive. I think the best place to go is just point your browser at tkb.mathsy.space. That is TKB spelt TEA as in the drink, KAYB .mathsy.space. I'm assuming that will be in the description below as
I think
well.
it's spelled the same way it's in the description below. Yep.
And if you go to that, there's links to all my social media profiles that I use. So that's probably the easiest way. Plus my website, which gives you more information about my Maths and Museums work, and some other links as well that might be interesting. You can find out more about my book there as well. So it's a bit of a link tree type thing where you can find out all sorts of things. But if on your social media platform of choice, if you search for TEAKAYB, you'll probably find me because that's my TKB is my handle in most places.
And that will also be spelled the same way as it is written in the description below.
Yes.
Brilliant. No, that's all right. It's an audio only podcast, but with written descriptions as well. Thank you, Tom, once again. That is it for today's episode. For regular listeners to the show, you will know I keep talking about my upcoming baby. So she is now due in, Monday as of the time of recording. But by the time this episode comes out, she will hopefully already have been born about a month ago. So I can't really tell you how long it's going to be before you have to listen to me again talk about a mathematician. Maybe another 2 to 4 weeks, and then after that I'll be back to writing more episodes again. If you want to find me on the socials, you can hear about any updates and find me on Blue Sky at mathematicians-pod. If you want to talk to Tom, you can find him on the link tree with all of the socials again in the description below. I won't ask you to spell them one more time. And that's it for us. So next time there is a mathematician that I can't wait for you to meet her. I will send a ping directly to your podcast platform of choice as we discuss Pingala, the ancient Indian poet and grammarian who invented binary. Until then, goodbye.
And goodbye from me.
The music today is Dance Macabre Finale by Kevin MacLeod. You can find more information in the show notes.